Good morning. Thank you for joining us today for the 23rd Annual Arkansas Soil and Water Education Conference here in Northeast Arkansas. I'm Dr. Tim Burcham, and I am the Director of the Northeast Rice Research and Extension Center for the University of Arkansas System Division of Agriculture. We're happy that you've joined us today for our first virtual conference sponsored by the College of Agriculture at ASU, the University of Arkansas System Division of Agriculture, the USDA Natural Resources Conservation Service, the USDA Agricultural Research Service, the Arkansas Biosciences Institute here at ASU, the Ecotoxicology Lab at ASU, and the Judd Hill Foundation. A special thanks to Dr. Mickey Latour and the faculty and staff of the College of Agriculture for providing my broadcast headquarters for today's conference. We're so excited to announce our new website for the conference, and you can check us out at arkswec.com to learn more about the conference, our poster presentations, and our presenters today. One of the benefits of participating in a live virtual conference is that you can submit your questions in the Q&A box, and we'll answer as many of those questions live with our presenters at the end of the session today. So make sure you hang on to the end of our presentation today. So if you're a certified crop advisor in need of CEUs for this live virtual conference, we'll post instructions for obtaining those in our closing credits. This conference has been approved for 2 CEUs for CCAs, and it's also been recognized for continuing education credits for the American Society of Farm Managers and Rural Appraisers. Next, we have our welcome from Dr. Mickey Latour, Dean of the College of Agriculture at Arkansas State University. Dr. Latour.
Good morning, everyone. It's an honor to have an opportunity to say a few words. I am Mickey Latour, the Dean of Agriculture at Arkansas State University. And on behalf of the College of Agriculture, I would like to express my great pleasure in welcoming all of you to the 23rd Arkansas Soil and Water Education Conference. I am new to Arkansas and would like to mention some things happening in our college. Specifically, we are moving forward with a strategic plan to align efforts. We're getting ever so close to launching a new multifunctional building near the current farmers market location to support education, research, and entrepreneurial efforts. And finally, we received $500,000 to make improvements to our meat laboratory and plan to move forward with seeking USDA inspection, which will expand opportunities for our students and faculty. Also, over the last 6 months, I visited and witnessed the great things going on in the Delta region, specifically across various crops, cotton, rice, water use, peanuts, soybeans, corn at farms. One of the most impressive components of those visits were the extensive collaborations between farms and scientists. I know through conversations, this conference has been attended by 400 plus individuals in recent years, and delighted to see the conference move forward despite the challenges of COVID. So I applaud everyone for making this great event possible. I value the level of collaboration across universities, cooperative extension, government, farmers, consultants, all pulling in the same direction, advancing research activities, and then transferring that information through educational outlets such as this conference. I strongly believe this conference plays a leading role in promoting scientific activities in the region and felt worldwide. Today is an opportunity to exchange information and promote findings that impact individuals across various fields of agriculture. I'm confident there will be new ideas expressed today that in turn generate new studies for scientists to uncover and report on next year. Success comes from commitment to excellence, and I want to thank the chair, Adam Eads, and members of the committee for assembling this program. I would like to emphasize that the work discussed at this conference will play a crucial role in agriculture as well as the environment. These topics are critically important to our future success, and thank all of you participating. In closing, I would like to thank all the speakers for their commitment to this conference and to the sponsors for help with financial support, and wish all a great conference. Thank you very much for your attention.
Thank you, Dr. Latour, for that gracious welcome. Richard Pickett, owner of P&P Consulting, will talk next about drone elevation data and its practical use. I'm really excited about this presentation. Richard?
Good morning. My name is Richard Pickett, and I'm the owner of P&P Consulting, as well as an accelerated master's student at Arkansas State University. Today, I'll be giving a presentation on drone elevation data and its practical use in agriculture. As far as a little background on myself, I spent 12 years in the military working in intelligence operations and analysis, and that is where I started my experience in drone technology. As far as my academic experience, I've been going to Arkansas State University since 2019, and am currently pursuing both my bachelor's and master's, as well as 2 minors, with a plan to graduate in May of 2022. My professional background in agriculture started in 2018, where I started my own consulting company, P&P Consulting, with plant health drone technology. And then more recently in 2020, we've moved towards elevation technology with drones in agriculture. We'll be going over my equipment. We'll talk about survey comparisons, elevation analysis, pros and cons, and then the future outlook of our company with drone technology. My current equipment is an EVX RTK PPK setup as with a Trimble GPS solution, as well as a Phantom 4 RTK solution. I have a fixed wing and rotary wing for different types of jobs that I'm conducting. The computer system is custom built by Puget Systems, specifically for drone photogrammetry. That way you can process more data. It's a very robust computer, very expensive computer, and it's more effective for me to use a local solution than say cloud processing because of my internet speed, et cetera. So if you're trying to get into this and you have very low internet speed, then you would want a desktop solution for your stitching software. And then as far as softwares, I use Pixworld Mapper, Terra Design, which is a Terracotta desktop software from John Deere, as well as ArcGIS Pro. Before we get into the comparisons, I want to go ahead and explain the different types of images we'll be seeing. On the left and the right, you have drone and ground elevation data. These are raw points. Neither side, left or right, has been surfaced or interpolated in any software. These are just the raw points that get pulled into the software prior to surfacing. On the left, you'll notice that there is a significantly more detail compared to the right. That is because on the left, the drone isn't doing survey swaths. The drone is collecting based on its camera setup and grid pattern parameters, elevation points across the entire field. On the right, you have the traditional ground survey of a 40-foot swath using a field level 2 Trimble system. Next, we'll move on to the cut fill ratios once these elevation data points have been surfaced. If you look at the cut fill ratios, you'll see that most are off in hundredths to tenths, some a little more. It just depends on the interpolation method as well as the swath width conducted when comparing a ground versus drone survey. But if you look really hard on different aspects of this, most of these points were off in the hundredths rather than tenths in terms of cut fill ratios, even on this very hilly field. Also to note, red is high, blue is low on everything we'll be looking at today. This is the cut sheet generated from the cut fill ratios and the cut map earlier. As you can see, we have a little bit of difference in total area. This will always be the case when using drone versus ground survey because you draw in the ground or the drone boundary and you drive in the ground boundary. So unless your GPS system is sitting right in the center of the edge of the field when you're driving your ATV or vehicle for the boundary, then it will never be the same as a drone boundary drawn in from imagery. The max cut ratios are within a few hundredths. The max fill are within a few tenths. The total cut volume is 2,900 yards difference overall. And it's a substantial amount of dirt moved because of the type of field it is. I mean, there is an 8-foot cut and a 10-foot fill across the field. But these were set with the same parameters, slope, direction. That way you could see the difference between drone and ground cut sheets on a very hilly field on a 40-foot swath. So a ground surveyor probably would have done a more tighter swath than 40 foot on this. Just at the time, we were in a hurry to get the data collected, so we did it in 40-foot swaths before the sun went The reason why you're probably looking at 2,900 yards difference in terms of overall yardage is the drone picked up substantially a lot more area than the ground rig. So if you look, the drone picked up the major ditch that runs directly through the middle of the field, where the ground surveyor was unable to survey due to standing water and the depth of the ditch. As well as in the northwest corner of the field, there is a gap of data, even with the 40-foot swath, because it was so wet, the surveyor decided not to continue surveying up into that hill in the northwest corner, while my drone data did pick up the elevation change throughout that area. These factors all play into yardage in terms of cut and fills. So the fact that there was this much difference in data and elevation change and that much interpolation in the 40-foot swath, it's expected to have at least a couple of thousand yards difference in the overall cut sheet. Now moving to a more tighter, less hillier field in terms of comparisons. The left was a drone data, not surfaced yet. The right is a Trimble R8S system, which is for industrial survey equipment, using a base rover on 20-foot swaths. So a lot tighter, and then a smaller, hillier field. As just to state again, these are raw elevation points, none are surfaced. So you can just see how much more detail you get from a drone survey than you do a ground survey. So if you look at these cut fill ratios, you'll notice that they are a lot more tight, as well as most are in the hundreds in terms of elevation cut and fill ratios. This is likely due to the swath width at the ground surveyor doing 20 foot, as well as less hilly terrain. So here we have a lot less cut and a lot less fill in terms of getting our field in the correct condition for row water. The acreage was only off by 0.3, 0.2. The total cut area was roughly the same. Total field area was roughly the same. The max cut, again, was within hundreds. The max fill was within a tenth. The total cut volume compared to each other was within 37 cubic yards overall between both cut sheets, which could be attributed to that little small 0.2, 0.3 acre difference in terms of the overall yardage. And as you can see at the bottom, the plane setup is the same. So there's no variation between the type of cut sheet you're building for this field. Both were built with the same parameters, and we're within 37 yards overall in terms of cut fill ratios. This last one doesn't look similar to the other two fields we've looked at. It's because I do not have the raw elevation data from the TopCon surveyor. So what I did was I surveyed a field he's already surveyed and then gave him the raw elevation data to pull into his TopCon software to design the field in the same parameters. As you can tell, the bottom columns are from his TopCon system. The right-hand column on the right-hand side of the screen is from my design software. So we both used the same parameters with the same percent fall and the direction. And we both had exactly 196 yards per acre on cut volume, with a difference of 121 yards overall. And per his words down there in quotations, that those 115 of those 121 yards were attributed due to the difference in field size. He had 0.6 more acres than I did in terms of the size of the field, which means we were down to 6 yards overall across a rice field with a very low max cut, max fill ratios. So moving on from the cut fill ratios, now we'll get into the elevation analysis side of what all this software and technology can do. So this is a 400-acre pivot field with raw elevation data that's been surfaced. And the software that I use, you can bring this raw elevation, surfaced elevation data into the software and apply different layers on top of it to identify for example, elevation change off these ridges from the major ridge down to the bottom of the low areas of the field. You can see how much of a drop you have. Then when you go, you can apply a different filter to look at the depressions. So this gives you an idea of where you're holding water in your field to help you with drainage designs. Another filter that you can apply to it is flow direction. So this gives you an idea of how the water flows off of your ridges into your drainage areas and ditches. And then this as well is called the flow paths, which gives you an idea of how the water accumulates into a path-like flow pattern into a ditch and then out of the field. So when you overlay all of these together, you're able to really zoom in and understand how your field drains and where the good and the bad areas are in terms of where you need to put ditches and where you don't, and where they're not needed. So from there, I manually draw in off of those different layers combined where drainage ditches should go and create guidance lines for Trimble or John Deere software to auto track all these lines to where you wouldn't have to eyeball all your ditches in individual fields prior to planting season. The pros and cons of drone elevation data, there's a lot of both. Pros is the amount of coverage area you can do in a day. So between my small and fixed wing drone, I can cover anywhere from 250 to 1,500 acres in a day, or you can look at it by the hour. I can cover 100 to 300 acres an hour. There's potential to cover more, but that takes waivers and some other stuff with the FAA to accomplish that we're working on. However, say collecting 1,500 acres in a day, you're talking a long processing time. So maybe 24, 48 hours to get off that 1,500 acres processed before you can get it back to the customer. But it still enables you to collect more data in good conditions and work on that data, say prior to a rain, where you wouldn't be able to cover that many acres if you were using a ground rig system. Entire field elevation collection. So like we previously shown, it collects data points across the whole field. There is no swath pattern to interpolate. It's multiple, I mean, on the average, I do anywhere, depending on what the customer wants, from half a foot per point to 5 to 10 feet per point, depending on how they want to handle how their computer system can handle the amount of data. Another pro for us is being able to survey the ground when it's wet. However, standing water is not able to be collected with drone photogrammetry or LiDAR data. So big, large standing areas of water in the field will give you false readings of elevation height, just like grass will give you false elevation readings of elevation height with both drones and LiDARs. And I'll be showing some examples here in a second. And that's because drones can't penetrate vegetation well, which is one of the major cons, as well as water, like I just previously spoken on. And then another, it's not really a con, but it's a deterrent for most people, is it requires extensive geospatial information system knowledge, as well as photogrammetry knowledge and expertise to make all of this happen. So field conditions. On the left, this is an ideal field condition for drone surveying. On the right, obviously, that's not a great idea for anybody, but a ground survey rig can get in there and drive over that and get a truer elevation than a drone or LiDAR can. And I'll show you why. So this is a 3D point cloud of a field flown last week. As you can see the field, you can see the elevation or the different points all around through the field. To note, this is not imagery. This surface is 3D points. So all of this color and which looks like imagery are points from a drone elevation collection. So you'll see the pivot that was covered up in weeds and grass. On the right-hand side, you'll see tall grass that was, say, in a ditch. And in the background, you can see where trees were elevation points from trees were collected in the background. To further explain why you can't penetrate water, so this is a ditch. where you can see the water surface, and then you can see the ditch where the water's not coming through, right? So that elevation height is going to stop where that water is. It's not going to get the bottom of the ditch. And that applies to the same thing in a field. So if you have a very, half a foot hole in your field and it's full of water, a drone survey will not be able to pick that half foot fill up when you're building a cut sheet. Currently, we are doing a lot of different things with drone elevation data. We've collected field edge for doing polypipe or pipe pointer designs, used it to collect imagery of levee fields. That way we can calculate the acreage for a MIRI design. As I've shown you, cut sheets are almost spot on in terms of the differences between a ground surveyor and a drone surveyor in agriculture. So that can be used for farm management planning or post land leveling survey checks. Say you want a second opinion. It can be used for building auto track guidance lines for ditch and water furrows, as well as polypipe guidance lines along the center of ridges in your hilly fields where you water both sides of a ridge for pipe pointer. Our future implementations and what we're working on right now are levee creation with guidance lines, so to where we'll survey it with a drone, generate the levees, you approve them, we put them on a thumb drive, put them in your display, and you're ready to roll as soon as you get through planting. And then finally, the culminating part of drone elevation data would be full field leveling off a drone cut sheet. So right now, integrating the cut sheet with different GPS systems like Trimble and TopCon and John Deere. There's still some kinks that need to be made sure are fixed or understood before implementing a drone cut sheet, just because we operate in different things called datums and coordinate systems. So until all that's checked out and made sure it's right, then we'll be holding off on full field cut sheets. But that is, as soon as it gets dry enough, that's what we're going to start working on. This is an example of the levee potential. So on the far left image, this is a field I built a MIRI design for in 2019 based off of marked levees. So the old school way of putting in levees. And then in 2020, December 2020, almost 2021, I flew the field after it's been harvested in soybeans. It's been tilled up a little bit, but it's not slicked off for what you would use to start marking levees. So I flew it just to get a rough elevation and see if I could generate levees similar to the ones that were generated in 2019. That's the middle picture. And then the right picture is the overlay of the 2021 levees over 2019 levees. The main reason why most of them aren't closer in terms of like overlaying on top of each other is because you're overlaying two different coordinate systems and datums on top of each other. So in 2019, I was using a drone that's not RTK. In 2020, 2021, the drone that collected the middle and the red lines in the right picture was a RTK corrected drone. So there is anywhere from 5 to 30 feet difference in where these levees fall in imagery. So that's why most of the lines don't line up perfectly. But as you can tell, the shape and the direction and the fall of all the contours on a 2/10 fall are similar, if not almost exact, throughout the entire field for levee auto guidance for this coming year. In conclusion, I would like to thank many people, but these are just a few for the people my professors from Arkansas State University, Dr. John Allen and Ahmed Hashem. I would also like to thank the irrigation guru, Mr. Mike Hamilton from the University of Arkansas, Division of Agriculture, as well as Adam Eads from NRCS. All of these people have been great help to me over the past 2 years and get my business ideas bounced off of, applying for maybe grants or just anything I've needed. And most of all, you can't forget the growers. So Mr. Scott Matthews at MFP Farms, he is pretty much the guy I bounce every idea I ever have off of. He's my sanity check when it comes to agriculture technology, especially in rice and soybeans. The next ones are the farmers at Felton Farms down in Lee County, McClendon Farms down in Lee County, and then TNA Farms down in Phillips County. All these growers have worked with me to do land leveling, auto guidance lines, ditches, and then more farmers are looking to start implementing the levees this year. So we're going to have a lot more growers to thank after this year. And finally, I would like to thank the Arkansas Soil and Water Conference Committee for allowing me to speak to all of you on my company, drone technology, and what I'm doing with elevation in agriculture. Thank you for your time.
Thank you, Richard, for sharing about the practical uses of drone elevation data. Just really fascinating information that you presented there. Please remember to all of our attendees today that you can enter your questions into the Q&A box, and we certainly want to welcome you to do that as each of the presenters are doing their segments today. And we'll get to those questions, as many as we can, at the end of the presentation today. Next, we have a small break before our next speaker to acknowledge our sponsors for today's presentation. We certainly want to thank our sponsors for their support. Next, Dr. JR Rigby, a research hydrologist with the United States Geological Survey, will share some very interesting information about the Mississippi Alluvial Plain. Dr. Rigby.
Thank you. My topic today will be system scale science to support water resources, the present and future of the Mississippi Alluvial Plain project. Let me talk first about the general approach of the map to date. The map began in 2016, and when it was begun, there was an interest in trying to do things a little bit differently than we've done groundwater models in the past. Specifically, instead of having a single modeler who's working largely in isolation to put together the available data sets, we wanted to use all of the available modeling resources, and where some data sets might be sparse, to try to use complementary models to provide the inputs to the groundwater model. So we've focused on integrating models across the region to provide the best estimates of the inputs to the groundwater model. In addition, we've focused on iterative and co-produced products. That means that we've tried not to just wait 5 years to get any product out, but try to get versions of the product out as quickly as possible, and to get as much stakeholder feedback in the process of producing the various modeling products as we can. We've also made an emphasis of investing in long-term data sets for the region. The biggest one of those that I'll talk about shortly is the Airborne Data set that we've put together. We've also used a combination of machine learning and process-based models. As many of you might be aware, the history of modeling natural resources has focused on physically based models, using the basic flow equations for groundwater or other constituents to model the system. Nowadays, with big data and machine learning methods, if you dropped Amazon.com or Google into our region and asked them to model groundwater, they probably wouldn't go with a physically based model to begin with. They would try to use machine learning based methods. So we've tried to use a hybrid of these two things where appropriate to use the data to its full extent. We've also focused on developing new tools, not just applying the tools that are available within the USGS, but using the platform of the map to develop new ways of doing things internally. And I think this has made us a little more nimble when it comes to modeling. And then we're working on designing long-term monitoring. Instead of this being just a 5-year research plan, that we want to come out of this with a better understanding of what networks we need in place long-term. One data set that we've invested in that we think is a long-term investment for the region is airborne electromagnetic surveys to map the entire aquifer system from Missouri to Louisiana. This is the largest airborne electromagnetic effort for water resources mapping in the continental United States to date, with a total planned flight line distance of 50,000 line kilometers. This was flown in basically 3 phases, beginning in February to March of 2018, and culminating this year when in the spring we'll fly another 5,000 line kilometers of resolve surveys, and then follow that up with the final component of our regional survey. I think we're going to see that this data set is a game changer in the region in terms of the robustness for applications in all kinds of areas. We've recently submitted a manuscript on this data set, and within that we find applications as broad as from earthquake histories to the early geology of the region to its intended purpose, which is better mapping of water resources flow pathways. This data set gives us really 3 data sets in one from the 3 instruments on board the aircraft. The first is radiometrics. This gives you the relative concentrations of uranium, thorium, and potassium in the upper 30 centimeters of the soil, or the upper 1 foot of the soil. This is really just giving us the mineralogy of the soils at the surface, and it corresponds very closely to existing soil surveys from NRCS, for example. In the middle here, you see the electromagnetic resistivity. This is the primary data set, and it gives us a 3-dimensional picture of the aquifer down to about 200 meters below the surface, or about 600 feet below the surface. And then on the far right, the magnetic data is measured by a magnetometer on board and is really responding to changes in the rock density very deep below the surface. So this is on the order of kilometers below the surface and shows some of the geometry of the basement rock in the region. What we use the Airborne for, as I mentioned, there are a wide variety of applications. One of them is mapping the base of the aquifer, and we've done some preliminary comparisons using the Airborne data to compare with existing bases of the aquifer derived from boreholes. Here in the left figure, you can see the borehole-derived base of the aquifer from a 2019 publication. In the center, you can see the base of the aquifer using the Airborne data. And to the eye, they don't look very different. But if you take a difference map, just subtracting the elevation of the base of the aquifer between those two surfaces, you get the figure on the right, where the dark reds represent an elevation difference of 20 meters or more, and the dark blues represent a positive difference of 20 meters or more. And throughout our aquifer, the average thickness is about 35 meters. So anywhere you see differences of on the order of 20 meters, we're over 50% different in the total potential saturated thickness of the aquifer between those two estimates. So the Airborne has the potential to revise our understanding of the geometry of the aquifer substantially. In addition, one thing that we didn't have in mind when we first flew the Airborne, but has subsequently been a very interesting venture, is that we flew some of the rivers in the region to see what the bed of the river looked like in terms of bed material. On the left, you can see a map of all the rivers that were included in the original MIRAS regional groundwater study. It's about 43 rivers. And there was, at the time, no information on the bed material from those rivers to help guide the calibration of the groundwater model to understand how much water was moving from the river into the aquifer or vice versa. Like I said, when we started the surveys, we flew some of the rivers just having the helicopter fly along the river so that we would get a picture of the bed material. What we realized, though, is with 50,000 line kilometers of east-west flight lines, we could just take those lines and select the points that occurred over the rivers and use that to map out the rivers. So the figure on the right has taken the NHD plus flow lines that exist as a USGS database and intersected those with our flight lines, and it gives us a much denser network of streams with information about the bed material. So everywhere you see a stream mapped in that figure on the right, we also have information from the Airborne data, and the blues and the yellows are represent an index that we developed to estimate whether we think there's high conductivity or low conductivity between the river and the aquifer at those points. So this is already light years ahead of where we could have been with the previous model. To wrap up the Airborne, one thing we've been conscious of is the return on investment. We've termed this connecting the dots with airborne geophysics, the dots being boreholes in the region. If you look at the figure on the left, that's another representation of the base of the aquifer. That was based on about 10,000 boreholes. It took decades to collect those boreholes, and those were conducted by different groups in different states for different reasons with a wide variety of data quality. And if you add up the total drilling costs, it cost about $200 to $300 million to collect those 10,000 boreholes. On the right, you can see the comparable base of the aquifer. That's based on 17,000 line kilometers, or about 1 million virtual boreholes. It took about 3 months to collect all of those 1 million virtual boreholes, and it cost less than $1 million. So while the absolute cost of Airborne is relatively high if you're putting together a survey, the cost per data point is very low, and you get not only a broad coverage with consistent data quality, but you get it at a fraction of the cost of comparable coverage with boreholes. As an add-on with the Airborne, we've collaborated with the U.S. Army Corps of Engineers. We did a pilot study about 1.5 years ago to look at the use of airborne data to evaluate the material along the Mississippi River levees. And the Corps has decided to fund a complete survey of the levees. So later this spring or early this summer, we're going to fly lines along the entire lower Mississippi River levee system to help the Corps better target their geotechnical investigations and help the flood fighters know where they need to add clay blankets and that sort of thing. So this is an add-on to the MAP project. It's funds coming from the Corps, but we've been able to leverage the other work that we're doing in the MAP to help the Corps fight floods along the Mississippi River. Somewhat as an add-on to that, we've expanded our work with the Corps. The Corps has a lot of flood fighting capacity, and they have models associated with flood forecasts. One thing we didn't have in our groundwater models was good representation of stage in the streams. As I mentioned, the Airborne has given us a much better picture of the connection between streams and the aquifer, but we didn't have good control on the stage. So we've teamed up with the Corps on a proof of concept effort to take their HEC-RAS models from the Mississippi Delta region and calibrate those for within bank flow and use their surface water models to solve for stage and use that stage to drive surface groundwater interactions. If this works out, we'll expand this across the MAP region, and I think it'll be a great example of the Corps' surface water expertise being combined with our groundwater modeling that's already been going on to provide a better product. So since I mentioned groundwater modeling, we now have 5 total models under construction or in some stage of construction associated with the MAP project. There's the larger footprint update to the MIRAS regional model. And then we have 4 inset models within that. All of these models are being produced in ModFlow 6, which is the latest and greatest version of ModFlow. It's a complete rewrite of the ModFlow framework and is brand new within the GS, so our modelers are getting early adopter expertise in ModFlow 6. One of the key differences between ModFlow 2005 and ModFlow 6 is the ability to create inset models, and I have a little cartoon here of what insetting means. Basically, for the Grand Prairie and Cache inset models that I have marked out there, we can either run these models as standalone models just for those regions, or we can plug those models into the regional model and treat them as local refinements. So it gives us the ability, if we want to do lots of scenarios for the cache, for example, we don't have to solve the entire regional model. We can take the cache out and run it independently. On the other hand, if we want to run regional scenarios, but we want the added detail in the cache, we can plug the inset model into the regional model and run the whole thing. So that's a great advantage. It gives us direct communication between the regional model and the inset models for boundary conditions, but also gives us the computational capacity to run a lot more scenarios on an individual inset. Those 4 insets, as I mentioned, we have the Cache and the Grand Prairie, focused on different projects in each of those areas. There's one for the Mississippi Delta side as a whole, and then within that, there's a project site associated with the USDA groundwater injection pilot project. And we've been able to do all this not just because ModFlow 6 is a new platform for ModFlow development, but because Andy Leaf on our MAP team has been developing new automation tools for speeding up the modeling process. We put a big emphasis on our groundwater modelers working in teams, doing team modeling sprints, and Andy has developed software tools to take the process of constructing all the files to build a groundwater model from a matter of months to years down to a matter of days to weeks. In fact, we had a modeling sprint just before the end of the last fiscal year. It was a 3 or 4 day sprint, and we were able to get the skeletons for 3 of these models built within that 3 or 4 days. So it's significantly increasing our response time for building models. So in the future, if new projects crop up or new issues crop up that we need to investigate, the ability to use these automation tools to construct models more rapidly will let us more economically and in a timely fashion respond to these needs. Part of the emphasis for MAP was always to try to bring in economics to the picture. Our economics team has put out a fact sheet on the economic impact of groundwater and agriculture in the region. As we're moving towards the end of the first phase of MAP, where we're trying to incorporate all of these components into decision support, They're also working on cost function models for groundwater and for surface water groundwater partitioning. And they're also looking at developing relations for regional valuation of groundwater decline. The goal here is when we see model forecasts for 1 foot or 10 feet of model decline in the long term, what's the economic impact of that to the region, at least our forecasted impact to the region. I think that'll help regional decision makers with tough decisions down the road if they see what the economic impact is likely to be. And then part of that is developing more sophisticated forecasting capabilities. In the past, we would just take whatever the final year in the data was and extend that year into the future when it came to drivers like the crop distribution on the landscape. Our economics team is working to use crop commodity forecasts that come from USDA that go out 1 or 2 decades and use those commodity forecasts to better represent what the likely changes in crop distributions on the landscape will be, and we'll build those into our forecasts in the future. And finally, in terms of what we're working towards on the data side, we want to do network optimization. This is something that's been on our minds with the map for several years. We're getting to the point now where the models are mature enough to help us with network optimization. But rather than looking at the map as a one-time study that puts out a model that's then used and likely obsolete in a short amount of time, we want to use the models and the insight that we've gained to design long-term data collection networks that are going to feed the model and improve the model over the long term. So instead of map coming and then going away, the idea is that we finish this first phase of map, and that ends with a set of data collection networks that have been either reconfigured if we have all the infrastructure we need, we just might need it in different places, or that we've added to it where we need additional data to really help make decisions in the future. And this extends to groundwater level monitoring, as well as water use, and even to some ET network monitoring that we're getting into. And all this culminates with our decision support component. Decision support means a lot of things depending on who you talk to. From my point of view, what we're trying to do is combine 3 pillars: data access, integration, and scenario support to provide information to decision makers. For data access, I mean we want all of our data to be available at a single stop. So in this case, a web interface where you can go and see all of the USGS data sets that are being collected and aggregated into the map. And if you want to know where water use is being collected real time, you can go to that website, find the real-time water use network, and look at the data from that site. Integration means that we're taking all of the available data and not just handing you the data, but integrating that data into something that takes into account all of the implications of the data sets. Usually that means models. So we're doing the background modeling to integrate all of those different data sources. And then with those models, we're providing scenario support. I think it's important if we're trying to make decisions, not just to define a single optimal path or to tell you where you are now, but to give you some idea of, based on which choice you make, how bad will things get or how good will things get. So providing scenario support based on where we are now, updating that hopefully on an annual basis, so that each year when we're making regional decisions, we can see how last year's decisions factored into the current situation. And then scenarios ideally should show a range of possibilities. We should show more sophisticated scenarios for weather and climate, and show, for example, a dry, wet, and normal scenario going forward, and what's the implication for each of those for a 5-year, 10-year, or 20-year horizon. So this should all be put together in a version of a decision support dashboard, hopefully later this year. We're going to be working on this iteratively this year. The first goal is to get those USGS data sets delivered to a web portal. We're also working on a web-based data viewer for our airborne data. I think many of you have seen me give presentations, but we'd like to have kind of a 3D surfable data set on a website by the end of this year through a web app. To do that, we've had to do some new things. We're defining a new file standard for airborne data. This will be something that's used probably by the national community, if not also the international community going forward, that lets us grab that data with data servers and plug it into web apps. And then we're working on the model forecasts. And ideally, this would wind up being state-based because we have those inset models. So Arkansas's interests for model forecasts are different from Mississippi's or Louisiana's. The first order version of the dashboard will be from the regional standpoint, but then we hope to refine to state-based dashboards from there. With that, I just want to thank my MAP team. This was a picture from our last pre-COVID meeting. There were about 70 people who contributed to this with stakeholders all across the region. Thank you very much.
Thank you, Dr. Rigby. We have certainly learned some very interesting facts about the Mississippi alluvial plain, and I'm just really amazed at the technological innovations that are being employed by the USGS. Remember, if you have a question, please enter your questions into our Q&A box. You'll find that link at the bottom of your viewing segment there. And again, we'll answer as many live questions as we can by our special guest speakers today at the end of our session today. Before we have our Most Crop Per Drop Award presentation, we'll have a small break to recognize our sponsors. And so stay tuned and we'll have a break to recognize our sponsors, and we'll be back with our Most Crop Per Drop Award presentation. We certainly appreciate our sponsors for their support. Next, it is my pleasure to share the Most Crop Per Drop Awards. Dr. Chris Henry and his dedicated research team have awarded first, second, and third place winners for the Most Crop Per Drop contest in the categories of corn, rice, and soybean.
The winners of the 2020 University of Arkansas Division of Agriculture Irrigation Yield Most Crop Per Drop contest are for the corn category. First place, Chad Render. Second place, Terry Smith. And third place, Brandon Kane. Here is a message from Chad about the contest.
I do want to thank the sponsors for making all this enticing for the farmers to join in and actually, you know, be a part of this program, because it doesn't take that much effort when you have people with the university making it, I guess, easy for us to do these practices, like, you know, the pipe planter, the moisture sensors, the valves that y'all offer us to, you know, just try. And then once we try this stuff, you know, from my personal experiences, I'm seeing benefit on less water and, you know, more yield. So at the end of the day, I appreciate what y'all are doing and the effects that's coming out on our bottom line. And, you know, the good Lord is not making any more of this land. And so the more we can conserve and, you know, try to treat the land as good as we can and conserve our water consumption, that's what we're trying to do at the end of the day. Scott Crabb had introduced this program to me through the schooling that y'all put on through the NRCS offices. And anyway, he made it real simple for me to join in. And last year I tried it with the soybeans. This year I did it with the corn. And you know, it worked out really well with the corn this year. We had good rainfall, and we monitored our waterings that we had on the corn. I do want to thank the Extension Office, Kurt Beatty here in Jefferson County, and Scott Crabb with the NRCS office, and then Greg, whenever he comes out to do the yield trials. I mean, he's super. He knows we don't want to stop to do anything as far as you know, more than we have to, but he makes it very simple and painless for us. And you know, and just the guys that help us on the farm, you know, they're top notch, and everybody makes it easy for us.
The winners of the rice category are first place, Cody Fincher, second place, Seth Tucker, and third place, Clint Bowles. Next is a message from Cody about how he managed his rice field.
A buddy of mine, James Ray, actually turned me on to the contest and got me in contact with Mr. Greg, and I kind of entered it a little late. You know, I think we were getting ready to water rice like the following week. So Mr. Greg didn't waste any time and got right on out there and got me set up. And I think the biggest reason I was successful is because of the field that I chose for this contest. You know, it was just one of them that's leveled on an 05 and doesn't have the best drainage. So I knew it would be a good fit for the contest, you know, as far as saving water and everything. But I think the biggest thing that I did was just I managed it a little more closely, kept my eye on it, and I didn't use any sensors or anything, but I was able to, I think all summer I only turned the well on 4 times. You know, we caught a couple rains here and there, and what I would do is basically just make sure I didn't lose any water on the bottom end, and I would let my top go as long as it possibly could, which, you know, had this field not been in that competition, I would have started the well a little sooner, but I was just trying to go as long as I can before I can turn the well back on. So I think that was key there. I got lucky and had a pretty good yield on it. You know, I didn't really expect to do that good on the yield, but my goal going into it was just, you know, save as much water as possible. So
the winners of the soybean category are first place, Jeremy Wiedemann, second place, John Allen McGraw, and third place, Ryan, Mike, Scott, and Gavin Sullivan Family Farms. Let's hear from Jeremy about his experience with the contest.
You know, I would like to thank all the promotion boards and the sponsors, because, you know, it gives us something to something to chase, a kind of a goal. And, I guess I'd back up. My first job on the farm was watering. So from day one, that's all I've done, and I'm still doing it. So that's what got me encouraged in the irrigation school and the sensors and all that. So that's kind of, the contest interests me because I've always been irrigating. So we've been told we're overwatering, and it, I'd say so after what I did this year. But it's still a matter of reading the sensors and trusting them, and using them to determine when to water. Obviously, and Greg stressed this to me from the start, the yield's not everything. The irrigation is important. And like I said, I haven't seen the results, but I would guess my yields are toward the bottom. But the irrigation wise, I've proved you can save a lot of water. And that's what, that's what I'm going to use going forward, is try to just use less water.
Special thanks to Greg Simpson, Arkansas Natural Resource Conservation Service irrigation technicians, county extension agents, and the sponsors for making the contest during the pandemic a success.
Now Adam Chappell, a regenerative farmer from Cotton Plant, Arkansas, will discuss plant intensification and profit versus yield. Adam, welcome to today's program. We look forward to your comments.
Thank you, Dr. Burcham, and thanks for having me. This is a topic I'm pretty passionate about, soil health and all. Just it's changed our operation, and we try to make it better every year. My title slide here, I just want to draw attention to the picture there. That is a field on a friend of mine's place in Australia of an ancient wheat variety called spelt. And that plant in that field was planted at 17 pounds per acre. So that is an extremely low rate compared to our wheat plantings. So, plant intensification is a great way to grow roots and save money from seed and things. And you can see the stand behind him. I mean, that's going to cut tremendous wheat. So we're going to kind of talk about that in pretty broad strokes today. If y'all don't know who I am, my name's Adam Chappell. I farm in Cotton Plant, Arkansas with my brother. My dad retired in 2014, but he's still around keeping the office going and keeping us straightened out, I guess. But we started working with covers back when he was still in business. In 2009, we kind of started looking at ways to fight pigweed. And if any of you have seen me talk before, you've probably heard that story. It's a story for another day. But through that transition from full tillage, traditional Delta agriculture to now, we've maintained competitive yields, but we've reduced our input costs by, 50 to 60% compared to where they were prior to this. So it's made a huge change. And through this journey also, we were founding members of the Arkansas Soil Health Alliance. So any new guys getting ready to try cover crops and things, it's a great resource for you. I'm a proud graduate of Arkansas State University. I got a degree in botany and then went on to the University of Arkansas and got a degree in entomology, master's in entomology. And both of those degrees, I came from an ag background, but I didn't stay in the ag field. I ventured into science, and I think that helps me think a little more critically than I would have just coming straight out of an ag school. I've got a little more skeptical mind, I think, than I would have otherwise. But, what I've figured out here is, and this is a saying from a podcast I listen to. This guy says this every day, that every decision in agriculture is good for somebody. But the question is, who's it good for? So, that's led me to a few questions I want to ask today. First one being, why is everything in industrialized ag focused specifically on yield? All the big companies' breeding efforts, all of the fertility research until recently has been based on pushing yields, fungicides, foliar feeds, everything has solely been pushed to force yields forward, and nothing has been mentioned to profitability. You can chase the yield rabbit down the hole, but you can go broke doing it. So, but all these things are pushed on farmers through advertisements from Big Ag that promise bushels if you use their products, or if you don't use their products, it's going to be a catastrophic failure. I mean, that's every day. You listen to any country radio station, you're going to get that. And if I got the bushels guaranteed to me for every product I've ever tried, I probably wouldn't be farming anymore. I'd be sitting in the Bahamas or something. But the second thing I want to talk about is who's making the decisions on your farm that impact you financially. I mean, that's a real question. I hear a lot of farmers call me asking about cover crops and no-till and things, and I kind of tell them a basic starting plan, and the first thing I hear is, "Oh, my consultant will never let me do that." Well, I've never had a consultant write me a check, so as far as I'm concerned, they work for me. And if I want to make a change to increase my profitability, they need to figure out the lessons that I'm figuring out. But if you put all your stock in these people, retailers, company agronomists, et cetera, where's their information coming from? Are they just chasing the yield rabbit also? Are they falling victim to that same advertisement and research that's solely focused on yield? If so, you got to wonder, how that's going to affect your bottom line, because, all the decisions that are being made are good for somebody. But if you just chase yield and you're using all these products that you really don't need, it's good for Big Ag. It's not good for the farmer. So, I want to ask my consultant and ag agronomists and things, my friends here, how many times have you told a farmer to use less of something? It's a rare thing in ag for me to get a recommendation or something, previous to my changeover, where I was told to use less of something. It was always spray these bugs. We're finding a few, so spray them, or, more fertilizer means more bushels. That's just not the case. So, how many of y'all are actively trying to lower yield instead of just protecting a yield goal, or lower inputs instead of just protecting a yield goal? Yield goals are made or broken by the weather and other things. You can't focus solely on that. So where do we find more profitable systems? What questions do we ask? What we got to realize is what we know about production agriculture is a drop in the bucket the size of an ocean. We know very little, and I know very little, but the more I learn, the better things get and the more things make sense. But we need to look outside of our own country, because we are propped up by serious safety nets, and those safety nets discourage innovation. They keep us trapped in systems that are, commodity based, that run of the mill, make the most you can make and hope you get government payments to bail you out. Like in 2020, 40% of a farmer's revenue this past year was made up of government subsidy, not crop revenues. That's a serious problem. So we're just going to talk about one of the things we're working on to try to decrease production costs, and it's a system called plant intensification. And I've just got a couple illustrations here on how seeding rates and spacing affect the architecture of different plants. So, it's laid out there for soybeans at the bottom, what different seeding rates and things can do for the plant. And you can see how each plant, when given more space, is able to produce more per plant. So you get the same unit of outcome, but for a lower cost per unit of outcome. The top picture there is some wide row cotton. We're working on this system for Arkansas. This is a buddy of mine from Georgia. His name's Alex Harrell. He sent me this picture this summer. The picture on the right there, the cotton plant on the right, is a 30-inch row planted at about 40,000 seeds, which is typical, even typical in Arkansas in places. And then the one on the left is his cotton planted on 60-inch rows at 9,000 seeds per acre. So not only did he out yield the 30-inch field, but his seeding cost was less than 25% of his neighbors. So when you're talking about a $600 bag of cottonseed, that is significant. But when you spread those plants out, they have more room for light interception. They make tremendously bigger roots. and that gives up plant more reproductive capacity. So one that we tried this year is called the System of Rice Intensification. Now I'm going to give you a little brief history on this. It was developed in Madagascar by a Jesuit priest, and I'm not going to try to pronounce his name. You can read it there and make your own stab at it. But he was down there doing work and watching these people grow rice, and he noticed that the people who planted thinner stands ended up with better yields at the end of the year. So they started pushing the envelope on that. And then in the 90s, Dr. Norman Uphoff from Cornell, he moved in there behind the Frenchman there and took it to a whole nother level and spread it around the world. So the things I want to point out about this system is the varieties that these people use, and this is third world countries doing this. The varieties they use are varieties that we consider to be ancient, outdated. We would never plant them here. They use alternate wetting and drying irrigation methods, which reduces their water consumption by at least 50%. And that's big for them because most of their water is rain caught. They catch it in a reservoir, put it on the rice field, so on and so forth. So they have to conserve water. They have a 90% reduction in the use of seed compared to their traditional seeding methods. Now think about what that could mean here in the US. Their fertility's limited to just compost. You know, most of these people don't have access to commercial fertilizers. All their labor is done by hand. And the thing about it is these people in these countries by hand are achieving yields that are way better than I ever make. 250 to 275 bushel per acre is their average with this system in these parts of the world. Now they may be only farming an acre, but still, when you spread that over the entirety of the system in the region, that is a tremendous rice yield. I mean, I don't know many people that are hitting that yearly. I know I'm not. I don't even get close to that. I'd love to, but you know, why have we not heard of a system like this in the U.S.? You know, and especially in Arkansas, we're the largest rice producing state in the union. You know, why did I have to look on the internet and find something about a Jesuit priest in Madagascar to find out about rice intensification? My theory is you can't sell a lot of seed when you reduce your seeding cost by 90%. But anyway, so these people, they float their seed for rice quality. They reuse seed, so they're growing conventional varieties. But the traditional seeding rate for SRI in these parts of the world is one plant, one seedling per square foot. Now, that rate hit me pretty hard when I first read that, because that is a rate that is significant in Arkansas. It's a rate that a seed company that we all know uses to determine whether or not you're eligible for a replant. So that seed company has determined that if you have one seedling per square foot, you're not going to get a replant because you have enough rice seed to make your optimum yield. So let that sink in. That equates to just a little over 2 pounds to acre. Okay, so they've actually spread their seedlings out to, I've seen studies with as much as a 48 by 48 foot, or 48 inch by 48 inch square. So, you know, there's a lot of variety there in the spacing, but optimum is 1 foot square, one seedling per square foot. So can we adapt this system to modern farming in Arkansas? I don't see why we can't. You know, we have the ability now to singulate rice seed with these precision planters. This is our setup that we put together this fall. We had Precision Planting and Vantage Mid-South make us some seed plates so we can singulate rice seed. We've got superior varieties with disease resistance and herbicide tolerance and huge tillering capacities. You know, our weed, insects, and disease management systems are got to be light years of beyond what these people are dealing with. And our irrigation management can be so precise. You know, it's easier than just flooding the field and letting it dry, flooding the field and letting it dry. So we can definitely modify this to fit here in Arkansas. So this is the importance of singulation. This is my consultant, Craig Shelton's daughter, Charlotte. I'm not sure she doesn't work harder than he does because she's the one always pulling the plants up to take the pictures with. But this just shows you the difference in architecture from our system. So the plant on the left is a plant planted at 22 pounds. The plant on the right is one of ours, and the left was planted 7.5 inch drills. And then the plant on the right was ours planted at twin row 38 inch at 6 pounds. Now the amount of tillers on those plants and the difference in maturity was very striking to me when Craig sent me this picture. And that is solely because of the spacing that we gave those plants. So, you know, we've got to exploit the ability of these plants to tiller, these hybrid varieties especially. And a single seed, you know, when you put it and give it space, it has exponentially more capacity to produce rice than when you clump a bunch of them together. The clump and the single seed may produce the same amount of rice in the end, but your cost per unit of production is a lot less with the single seed. It just makes sense. So planting, this is the planter we used. We did some of this in cover crop. We did some on bare soil. You know, we're big on cover crops, but we're still developing our rice system. But we planted 6 pounds per acre on a twin row 38. And we, like I said, we use VSEP precision meters with plates that Vantage put together for us to singulate rice seed. So really simple. We hadn't changed anything really as far as a production model yet. So this is one of our better fields. Now, we planted rice late this year, later than we've ever planted rice, later than we were comfortable planting rice. And we needed September to cooperate, and it did not. We had a lot of cloudy days, cooler temperatures. We ran out of time, but this is the progress through the season. So seedlings here, you know, starting to close canopy, there it is making heads, and then it harvests. This field ran about 150 bushel per acre. And like I said, it was one of our better fields. So, you know, the first thing that I heard when I was talking about my lower yields was what I should have planted more seed. Well, we did that. We had a trial here on farm, 12 pounds. So adding seed to this did give us additional yield. We got additional yield that gave us an extra $30 per acre, but the additional seed cost ran us $56 an acre. So we had a net loss by increasing our seed, you know, of $26. You know, that's so adding more seed in our scenario did not make any sense. Now, if we had adjusted the spacing, maybe so. Maybe some more seed with a different spacing would have made difference. But my conclusion was time was our most limiting factor. We've also done this with cotton. This intensification of cotton is an Australian system. A guy named Martin Hockey from Australia is helping me with this. It's the same principle as what we're trying in the rice. We're trying to get more units of production with less cost. So we run wider rows, 76-inch rows. And this field that you're looking at was 20,000 seeds per acre. This coming year, we're going to run 12,000 seeds, but we're very comfortable with cover crops and cotton, so we use those extensively for weed control. And as you can see, we were able to keep our cotton clean through all the stages of growth there with very little herbicide input. So the biggest thing that we found with the cotton and the rice as well is the bigger root systems. The root systems on these plants, when you give them space, is just amazing how much bigger they are. They're exponentially bigger. So, you know, if you worry about this seeding rate, you know, in Australia, they run as wide as 180-inch rows and 5,000 seeds per acre. So there's a lot of wiggle room in this system. But just the practical effect on your bottom line, just reducing your seeding rate. I mean, I've got an example here for hybrid rice and then again for cotton seed. So when you're talking, you know, the cost of bag for each of these, that's a substantial amount of savings that you can pile up. It takes a lot of rice and a lot of cotton to make up those gaps. So the bottom line is you've got to have time for these systems to work because you're relying on secondary, tertiary tillers and fruiting positions. So time is key. You got to get planted early. So the bigger roots leads me to fertility. You know, what do we know about fertility and all that? Well, the U of A does a great job, you know, with soil testing, but in a system like we're in on our farm, it's limited at best. It's, you know, it's constrained to a 6-inch rooting depth. Well, as I'll show you here in a few minutes, 6 inches of rooting depth is just the tip of the iceberg for us. So, you know, these tests always tell us we need to apply more of something because they're basing it on 6 inches, but you know, that's not good for us. That's good for a fertility company. You know, so You know, and why do we put so much faith in these tests? You know, maybe in a fully tilled 6-inch deep system, this is probably the most highly calibrated, you know, thing that there is. But for us, it's just, it means nothing. You know, it shows plant available nutrients at the depth of 6 inches. Well, you know, I have a serious problem with that because it doesn't take into account, you know, the biological portion of the testing or of the soil. It's just, you know, what they can extract with some organic acids in the lab out of a dirt sample. It just doesn't show a full picture in my opinion. So, you know, when you get into a biologically active system, this test becomes, you know, not really worth pulling. And, you know, it's usually, in my experience, not fertility that limits a plant to reach its maximum potential. It's usually something environmental that we can't control anyway. So this is why I kind of question the availability versus what's out there. You know, this is some data from a buddy of mine, Dan Prevost in Mississippi. He does total digestions and Malic 3s. And just look at sample 1 there at the difference between the total digestion of phosphorus and potassium versus what his Malic 3 has to say there. You know, it's hard for me to swallow the pill that says I've got to add P and K when I've got total digestion numbers of 600 pounds of P and 2,400 pounds of K in the top 6 inches. You know, that's just a hard pill to swallow. So the question to me is not, you know, what do we have out there that's available to the plant? It's how do we make the totals that are out there available? How do we increase that pool, or, you know, add, be able to get into that pool? So the answer is roots and biology. You got to farm more than 6 inches, and you got to have active roots, and you got to have a living soil. Now we do know there's several consequences to over fertilization. I mean, you know, KCl or potassium chloride, murate of potash, that's what everybody puts out for potassium. Well, it's 60 pounds potassium and 40 pounds chloride. It's also a great salt substitute. If you've got problems with sodium, you can go to Walmart and buy it, put it on your food. So this is a salt. We are putting salt on our fields. Now, I don't know how many pounds of chloride it takes to reach toxic levels, but if you're putting out several hundred pounds of murate of potash every year, you're going to get there. That's a problem. Phosphates in our soils, you know, soil scientists may disagree with me, but I have found them very inefficient, and they rarely correlate to any kind of increase in yield. We just don't get much out of them, so they're not really worth the money. We take sap and nutrient tissue analysis, and we're always good on these levels, so we just don't add them. And nitrogen is the one we abuse the most. Overuse causes increased attraction to insects through excess nitrates. Also, excess nitrates in the soil is strongly correlated to weed emergence and pathogenics in the soil. And also, it burns through what little organic matter we have left in our delta soils. It is just a soil destructor. So overuse is terrible. The way to get, you know, to small root systems is the overuse of fertilizers. So talking about roots, these are roots on our farm now. We used to be contained to that 6-inch level, but now, you know, this tape measure in the middle is, you know, 48 inches. We've got living roots. You can see them there. We dug this with a backhoe just to, you know, show how deep the roots went. We actually found roots at 76 inches in this hole. This is a cotton seedling straight after emergence, you know, straight down, starting to put on lots of fine roots. And then this is a soybean plant. Now, I've never seen soybean roots like that prior to our transition to soil health. That's one plant. And those things strung out about 25 inches before we started breaking them off. Now, how deep they really went, I don't know. But there's tremendous amounts of fine root hairs, and there's nodulation on all of them. Now, that's big for a soybean crop. You know, larger roots means more opportunity for rhizobia colonization and mycorrhizal associations. And that just means less water need and less fertility need. So roots are everything. Now, when you have bigger roots, you can depend on more than just the top 6 inches. We did some sampling at depth. So we did 0 to 6, went back in the same hole, 6 to 12, and then went in the same hole, 12 to 18. And these are the levels that we found in those spots. So, you know, when you add these 3 samples up, this is a Malic 3 extraction, and you've already heard my thoughts on Malic 3, but just for argument's sake, They're telling me in the top 18 inches, I've got 204 pounds of available P and 840 something pounds of available K, not to mention huge amounts of micronutrients and things. So once you can break out of that top 6 inches and get deeper, there's nutrients abound. So roots and biology, that's where we got to be. Okay, roots in the rhizosphere. So this is where all this happens. You know, I've got 3 examples here. I've got hydroponically grown wheat. You can see the roots are just white. They get everything they need from the farmer that grows them and puts it in that water solution. They take everything up from mass flow. There's zero association with microbes. The second field here is one of mine that is getting in the early days of transitioning to our full regenerative practice. And you can see a rhizosphere starting at the top parts of those roots, but the bottom parts are still naked. So this is a developing system, requires less inputs than the hydroponic system, but it's still getting there. Now the roots on the right is where you want to be. This is some been in the system a long time. This is that same consultant's picture, Martin Hockey. Those roots just germinated, and look, you know, the seeds just germinated. Look at the roots and look at the colonization around the roots. That is a healthy, active soil. That wheat is going to require very few inputs because the soil will provide it. So what's in healthy rhizospheres? Well, life, you know, mycorrhizal fungi, you know, nitrogen fixing bacteria, protozoans, you know, other predatory nematodes, insects, you know, just a huge amount of things. And they all do different things. But if you till your soil and salt it with fertilizers and things, you're not going to ever develop a system like this. Now, earthworms, how many of you even think about earthworms other than going fishing? You know, earthworms are huge for soil health, but they have to have a constant supply of food, which is soil surface residues from existing crops, you know, past cover crops. They got to have something to eat or they're not going to grow. And if you till and you destroy their habitat, they're not going to grow. But what can they do for you? Well, so if you can manage to muster up 1 million earthworms per acre, that's about 25 per cubic foot of soil. We, on our farm, we're running between 8 and 13 is our range. We hadn't made it to 25 yet, but if you can manage to get 25 per cubic foot, they're able to digest 36 tons of soil in a year. And the castings from that soil have an analysis of 4, 30, 73 of NPK. So when you multiply that by 36 in a year, that's a lot of free fertilizer. They're doing that for nothing. All you got to do is give them something to eat, you know, no-till plant residue. And also another big thing that's important for us in the Delta, when we get these torrential downpours, 5, 6 inches at a time, the effects of the burrowing by these earthworms, the channels they produce, can increase your infiltration rates by 60-fold compared to what they are traditionally in the Delta. Now think about what that means when you get a 5-inch rain overnight and you can increase that infiltration rate 60 times. You're going to capture all that water and you're not going to let your topsoil and your applied nutrients run off in the ditch with the runoff water. So here's just a quick example of how life in the soil can help alleviate a problem that we deal with constantly in Arkansas. Nematodes. I hear about nematodes all the time. Most of these diseases, deficiencies, pests, they're possible because of lack of life in the soil and poor soil structure. So nematodes thrive in an environment where there lack natural predators, and there's tremendous amounts of natural predators that feed on parasitic nematodes. You know, insects, tardigrades, centipedes, and then also predatory fungi. There's a fungi that acts like kind of like a Venus flytrap in the soil. It makes a little noose. The parasitic nematode gets in it, it's trapped, and then it digests it. So lots of cool stuff in the soil. So how do we build an active soil? You know, how do we do it? Well, the first thing we got to do is eliminate or greatly reduce tillage. I know in the South we get wet falls, we got ruts to fix, and that's all understandable, but we've got to do a better job about reducing our tillage. And then we've got to maintain a living root all the time in the soil if possible, as many days a year, because the roots of those plants, they exude sugars to feed biology, and then the surface residue that we lay down is the food for, you know, the earthworms and and the soil. It's a cycling nutrients, and it's also great habitat for, birds, mice, insects. All of those things feed on weed seeds and pest insects. But you just got to start adding life to get life. So I guess I'm kind of concluding here. We need to focus on profit instead of yield, and we can do that with a living system and really decrease the size of our environmental footprint at the same time. So, these systems are being done all over the world in places with no safety net where you sink or swim. So, why not try to adapt those to here? And who would most benefit from systems like this? I'd say farmers would. People like me, big ag wouldn't, because we'd be requiring less of their products, but they make plenty of money. They're making record profits every quarter. Farmers are struggling to get by. We've got some better prices coming this year, and I'm already seeing inputs going up. I mean, it didn't take any time. We hadn't even planted a crop yet, and inputs are already on the rise. So, but these companies are never going to promote a system like this. We have to take this into our own hands, figure it out ourselves, because a system like this is going to cut into the things they sell. So, we've just got to look at things, and we've got to push the envelope to figure out what we can get away with. So what I would tell you is, just because something's been done the way it's always been done doesn't mean that's the only way to do it. Just completely forget what you know and start over. Just change your mindset and try something new. I mean, let's take it to big ag a little bit. They take it to us constantly. So here's my contact information. I'll be glad to answer questions as long as my internet holds up at the end of this also. I'll throw it back to you, Dr. Burcham.
Adam, thank you. I always enjoy your presentations and appreciate you staying on board with us. But it's my pleasure today to talk about our poster competition. Again, direct you back to our website. That is arkswec.com. That website has all of the poster presentations available today. It's now my pleasure to announce the winners of the Arkansas Soil and Water Education Conference poster competition. That competition was divided into the following categories: bachelor's level, master's level, and the doctorate level. And again, these are all available on the website. At the Bachelor of Science level, the winner was Jefferson Pimentel, and his title is Evaluating Performance of Irrigation Timing and Efficiencies in Furrow Irrigated Rice. The second place contestant in the competition was Ellie Kuhn. Her title is Modeling Leaf Area Index and Canopy Height Using Growing Degree Days. Next, in our master's degree category, we have Anna Pieri. Her title is Long-Term Monitoring of Freshwater Mussel Beds in the Buffalo National River. The second place finisher in the master's degree competition is Margarita Levitt. The title here is The Effect of Ratoon Rice Cropping on Greenhouse Gas Emission and Harvest Yield in Arkansas. And our third place awardee in the master's degree category, Nicholas Craddock, Effect of Pasture Land Use on Subwatersheds of the Buffalo National River, Arkansas. In the PhD or doctorate level category, our first placed winner is Brittany Singleton. And her title is Riparian Land Use Along Two Sections of Bideview River. Our second place winner in the doctorate category is Amelia Atwell. Her title is Seasonal Contributions of Lead and Sediment in the Upper Cache River Watershed, Arkansas. And our third place finisher in the doctorate level is Maud Abogazle. His title is Investigation of Toxicity of Catechol and Hydroquinone in Freshwater Organisms. Again, I invite you to review the excellent poster presentations in their entirety on the Arkansas Soil Water Education website. And again, that website is arkswec.com. Next, we're going to do our Conservationist of the Year Award presentation. And that presentation is by Kevin Cochran.
Hello, everybody. I hope you've enjoyed the 2021 Arkansas Soil and Water Education Conference. I know it's been a little different this year. but I sure have enjoyed the last couple hours. One thing I look forward to every year is the presentation of the Arkansas Soil and Water Education Conference's Outstanding Conservationist Award, sponsored by Judd Hill. The Outstanding Conservationist Award is presented to an individual who is a leader in the field of conservation agriculture. 2021 marks the 8th year for us to present this award. This year's honoree is that true leader. For the past 24 years, he has served as a soil and water conservation specialist for the University of Arkansas System Division of Agriculture. During this time, he has implemented numerous programs and research activity to better assist agriculture producers and conservation professionals. He is a true innovator in the field of conservation agriculture. To better tell the story of conservation in Arkansas, he co-founded the Arkansas Discovery Farm Program. The Discovery Farm Program highlights the impacts of conservation practices implemented by farmers on their farms and is an envy of many states throughout the nation. It is my honor to present the 2021 Arkansas Soil and Water Education Conference Outstanding Conservationist Award to Dr. Mike Daniels. Congratulations, Mike.
Oh, thank you, Kevin. I wish I didn't have to wear this mask so you could see the smile on my face. I have long felt that this conference is the premier soil and water conservation education conference in the state. And so to be honored by this conference and my peers that organized it is very, very humbling and very, very meaningful. And I'd like to give thanks, I can't thank individuals, I'd leave somebody out, but all of our conservation partners that I've worked with over the years, our farmers, and those other colleagues within the Division of Agriculture I work with. I couldn't have won this without them and without their support. And I'm just truly honored, and the conservation community in Arkansas is such a great group of people to work with.
Dr. Daniels, just thank you so much, and such a tremendous honor. And I've had working a little bit with him. I can tell you this award was just so well deserved, and we really appreciate his contribution for soil and water conservation in the state of Arkansas. Does a great job. We're just a couple of 3 minutes into our Q&A, so we're really good on our time standpoint. So let's go ahead and make sure we've got Richard and Dr. Rigby mic check with you guys real quick. And of course, we know we've got Adam. So Mary, are we ready to rock and roll? All right. So our first question, I'm going to direct that one to Richard Pickett, and I'm going to double up this question, Richard, for the sake of time. The question is, what is the cost difference between drone versus traditional methods? And then a secondary question there was, what's the accuracy of the drone elevation data? I'm going to encourage all of our speakers today to try to be succinct in your answers so that we can get through as many questions as possible. So Richard?
Thank you, Dr. Burcham. As far as the accuracy, it's within 1/10 of a survey foot, so 1 inch roughly. In terms of price differences, it's almost similar to what it would cost for you to buy a whole setup for survey equipment. I think a Trimble field level 2 setup runs anywhere from $30,000 to $40,000 base and rover and all the software you need to conduct those operations. That's without purchasing a side-by-side. My drone system, so the smallest one, runs about 10 grand for the drone, say 5 grand for the computer, 5 to 10 grand for some software. So you're looking at a price difference of not much at all in terms of overall prices when you look at all the equipment you need for both. Thank you.
Great, thanks, Richard. Next, I'm going to ask Dr. Rigby a question. This question came in on our Q&A. It says, are there opportunities using new map project data about stream connectivity to make progress on managed alluvial aquifer recharge?
Thank you, Dr. Burcham. That's a great question. As I mentioned in the talk, we do have that data set that shows what we think is the connectivity between rivers and the aquifer across the region. We're putting that to use directly in Mississippi for the Managed Aquifer Recharge project at Shell Mound. So that's one example where we're trying to use riverbank filtration, but we could apply that same data set across the entire region. And I'd be happy to follow up on that offline if they'd like to discuss ideas.
All right, thank you, Dr. Rigby. And I just encourage you, even the questions that we're not able to get to today during our live Q&A, I'm sure all of our guest speakers today would be happy to try to answer those questions in an email and a follow-up to today's great conference. Adam, I'm going to put you on the spot here next and ask you, what was your herbicide program in rice? I think a lot of folks were certainly interested in that. And so that's one of the questions that's come in for you.
Yeah, it was pretty similar to what our normal rice program would be. We started with, of course, Roundup. Where we had cover crops, it was Roundup. 48 hours later, Gramoxone plus Command. And then on our standard, it was just Roundup or Gramoxone plus Command. Then we followed that with a shot of Command and Facet, and then followed that with Prowl and a little more Facet, I think. And then we had to do a little spot spraying from some barnyard grass that got away from us earlier with Rebel EX, and then spot spray some sedge with Permit. So pretty basic program. Seems like we might have had some rice bowl mixed in there. You'd have to talk to Craig about that. I should have had a list of that, but it was very similar to what we do on our flooded rice, and it worked really well. We were clean the whole year. I posted pictures through the year on those rice fields, and we didn't have any trouble keeping that wide row stuff clean. So that was encouraging.
Adam, did you have a general cost differential on your herbicide program that you could share as a follow-up on that question? Or is that something you could provide at a later time?
Yeah, I'd have to go back and see the exact cost, but like I said, it was very comparable to our flooded program, or our normal row rice program with thicker planting. So we didn't actually spend any more money than we normally do on herbicides, but we spent a lot less on seed. So that was the big deal.
Adam, as another follow-up here, we've had someone ask, what's the cost difference of running free soil samples through the U of A versus a total digestion sample?
Yeah, so total digestion is about $15 an acre. So, of course, you know, when you subtract zero from that, it's about a $15 difference. But, you know, we don't pull near as many total digestions. We just, you know, it doesn't take a lot to figure out you've got a lot. And we use Waters Lab in Mississippi. They do a great job with that. I'm sure other ones can do it as well, but that's just the one we've got a relationship with, and that's the one we use. So,
okay, thank you. Dr. Rigby, has the AEM revealed anything previously unknown about the aquifer or the subsurface in general?
Yeah, I think in addition to just updating our understanding of how the aquifer is connected to the streams and to the surface, one thing that we found that was unexpected was what looks like a major fault in the subsurface that's associated with the New Madrid seismic zone. We've found about 200 feet of vertical displacement over about a kilometer that runs northeast southwest. So that was surprising.
Okay. Thank you, Dr. Rigby. Richard, another question that's come in here is, what's the swath width of the drone that when you're doing your collections, they want to know what the swath width is in general. And I know that's impacted by the elevation you fly, but what are you shooting for on your swath width?
Yes, sir. Thank you. As far as the swath width, it just depends on the size of the field and what overlap I am trying to achieve. So for example, if I fly to 80% overlap with longitude and latitude, I can get anywhere from, I'd say 100 to 200 points to 1,000 points per feet cubed. Or if I fly at a lower overlap, say 60, I can get maybe 1 to 20 points per foot cubed. So it just depends on the level of detail I need for the project I'm working on. But the actual overlap, the drone creates that grid pattern based on how many points per foot or per meter I need in my data collection. Thank you.
Great. Thanks, Richard. Adam, got a couple of questions coming in for you. We've got about 5 minutes left in our Q&A. And again, just to encourage folks to continue to enter questions in the Q&A. And if we're not able to get to them in the live session, we'll certainly try to follow up with you. Says, Adam, are your rice fields in crop rotation, or have you tried planting the lower seeding rates with continuous rice after rice?
Yeah, so we try to keep everything in rotation. Most of our rice is 1-to-1 soybeans. But with this new row rice system, we're starting to incorporate it in a, rice, cotton, corn bean, everything. It's we can grow on sandy soils now because we're not trying to maintain a flood, and we're actually making decent rice on those soils. So we're really trying to expand the rotation on the whole farm with this stuff. So of course, as far as rice after rice, we have not tried this yet. We will have I think we will have 2 fields this year that'll be rice after rice in the same system. So we'll know how that's going to work. But for the most part, it's never back to back.
Okay. A follow-up there, probably not related, but another question to Adam there is, do you expect insect problems with the no BT or non-BT cotton you've planted for 2021? You've planned for 2021. And what about insecticide resistant bollworms?
Yeah, so, we've grown a lot of non-GMO cotton on our farm. When we went to the wide rows, actually when we went back to traded cotton, diamides still work pretty good on our place. I don't know that they're working everywhere, but we rarely have to spray for bollworms. We have an abundance of insects that when bollworms fly in, they don't last long. We've seen ant populations just harvest all the eggs off of plants. We've seen small larvae get totally decimated by predatory hemipterans. I mean, things that you just don't see in a field that gets constantly sprayed or doesn't have the habitat to support that. So insects really aren't a big issue for us on the farm. It's they're actually one of our lower priorities. Weed control is especially in the non-GMO is our biggest issue. We've been able to manage it good with cover crops, but it's a constant fight, and which it is in every crop. I mean, it's no different.
Great. Dr. Rigby, could you say a little bit about the MAP's collaboration with the University of Arkansas on monitoring evapotranspiration?
Absolutely. We're really excited to be working with Dr. Ben Runkle at the University of Arkansas and also with Dr. Michelle Reba at ARS. One thing that's really difficult to pin down at a regional scale is the amount of evapotranspiration that's coming off the landscape. And that makes up about 65% of the water budget. And it's really hard to find direct measurements of evapotranspiration. So the network that Ben and Michelle have helped put together is one of the best in the nation for measuring ET on crops. And the map is actually leading the USGS national effort in putting this together. So great to have that collaboration.
Great. Thanks, Dr. Rigby. Richard, I've got the last question for you, and this is going to close us out for today because we're just about out of time. And I think this one is certainly on everyone's mind, but how much faster is a drone survey compared to a ground survey, particularly when you take a computational? I know you talked about the, the Haas computer that you have to do the stitching and that kind of thing, but could you give us a little better understanding of that timeline?
Yes, sir. So for, one second, make sure I'm unmuted. Okay.
You're on.
So for the timeline, to give you an example, on that 40-acre field where I drove the 20-foot swaths, it took me 2.5 hours to survey that field due to the small ditches running throughout it in my vehicle. And it took me 30 minutes to survey with my drone. That time difference only increases as I move from a rotary wing to a fixed wing drone. So my fixed wing drone, depending on my altitude, I could cover probably 2,000 to 4,000 acres in a day if it's all closely related in terms of distance. It would just take me a long time to process, where a traditional surveyor would probably cover about 400 to 500 acres a day. So if you have a lot of bad weather coming in, you could definitely survey a lot more acres with a drone than you could a ground rig survey.
Great. Thank you, Richard. Ladies and gentlemen, let me say thanks to all of you that have attended today. We really appreciate you joining us for our first virtual Arkansas Soil and Water Education Conference. I want to thank today's speakers, our conference sponsors, the U of A System Cooperative Extension Service production team, and the Arkansas Soil and Water Education Conference Steering Committee for today's fabulous program. We hope you've enjoyed the virtual 23rd Annual Arkansas Soil Water Education Conference, and we hope to see each of you in person for the 24th edition in 2022. Until then, mask up and stay safe. This is Tim Burcham coming to you from the campus of Arkansas State University. We wish you a great day.